Glenn Morris here from the Smart Energy Lab. And today I've got Chun from REC back in the lab.
I'm back again. Thanks for having me.
Chun, last time you were here, you were talking about the REC's Alpha Pure R.
Yes.
What have you got for me today?
So we actually have our next generation of the Alpha series, the Alpha Pure RX, and I actually have a whole presentation here for you.
Okay.
But I'm not going to bore you with all the details, so we're going to speed through this really quickly because you already know what the Alpha Pure R is.
I love a speed preso.
Yeah, no worries. All right, cool. So, very beginning, the Alpha Pure RX is actually our 4th generation Alpha Pure panel or Alpha panel, and I like to call it like it's a remastered version of the Pure R because it takes a lot of benefits from there. And then we work to expand on the benefits of it. So I'll go through the slides and the benefits as I go along. But a lot of this, you probably might have heard it before. So a little deja vu might happen in your head. It's nothing to be worried about. You might have heard it before, right? So the Alpha Pure RX actually goes up to 480 watts on a residential home.
Wow.
And you can see the panel right behind us
Yeah.
right there. It's not, absurdly big or anything like that. It's still within, I think, around 2 meter squares. So you're fairly fine in bringing these panels up. The weight of it is a little bit over 20 kg. So it's not overly excessive in terms of weight-wise.
It's a two-person carry, as we did carry it in.
Yeah, exactly right. So if we can carry it in, I'm pretty sure everyone out there can be.
I mean, I've put the previous generation, the Alpha Pure R's on my home just recently, and they were similar size to these, but now you've got a few more watts as usual with the X on top.
Yeah, exactly right. There's another row up there.
Yep.
Put an X on it.
Yeah.
So we're still using the G12 cells, so that's fairly similar. And the reason why we use it is because we think it's the most efficient working cell out there on the market. And again, don't break what's not broken, or not don't fix what's broken.
No, just break it if it's not fixed. No. Just fix it anyway.
Just fix it anyway.
No, don't fix it if it's not broken.
Exactly. Don't fix it if it's not broken. So yeah, it's been working for us. We've got good feedback about it. So we're just going to work on it, build on it further, and just to increase the effectiveness overall in terms of that. So just to give you a brief overview, if any new viewers that come in and they don't know what the Pure R is about. So basically the Alpha series, it started off with a whole new design using the HJT cell technology.
Now this is your first acronym for the day. What's HJT?
So HJT is hetero junction. That's a H and a J. And then T is technology.
Right.
So hetero junction technology.
So I know that hetero means many.
Yes.
Yeah, or more than one.
Yes,
Okay.
and then the junctions is, the junctions in between in the cells itself. I'll go into that a little bit later, into more detail, because I do want to expand on that. That's our main selling point for this new panel that comes out. But let me just go through the RX first to just give you an overview on what the panels are. So really, it's a gapless cell layout. It is lead-free. You're still using the solderless bus bar connections and everything like that. There's no bus bars.
I love the gapless. It just looks like a beautiful sheet of black glass, as you can see behind us.
Exactly. Or maybe not, because it's black.
Yeah.
It just fades into the background. We also have a low temperature coefficient and also the warranty power of the panel after 25 years is 92%.
So what does it mean for the end user, low temperature coefficient?
So how I like to explain it is you use the solar panels when there's sunlight. And when there's sunlight, there's going to be heat. So when there's heat, you're going to have to trade off something, right, to absorb that heat. So with a low temperature coefficient, even though the panels are getting hotter, if you have a low temperature coefficient, you actually lose less power because of that fact.
Oh, because it's a negative coefficient. So as temperature goes up, power goes down.
Exactly.
But a low coefficient means less down.
Less down. That's the term.
Okay,
yeah.
so you're basically getting a high performance panel in, typical hot weather conditions or sunny conditions.
Exactly.
Yeah.
So we're trying to just kind of think the fact that when your panels are working, it's usually when the temperature is high anyway. So it's a bit of a seesaw because you want high temperatures, but as the temperature gets higher, you lose more power. So where is that sweet spot? That's the main question. And then the second question is, how can we reduce that further down? And so instead of trying to find a sweet spot, and which we have already, we just brought the whole temperature coefficient down, so you lose less power when it's working. Basically that.
Love it.
So as a whole as well, on top of that, the Pure Rs, it has highlight transmission, better durability because of our support bars at the back. It's using the N-type cells. Entire wafer, sorry. Quality is impeccable. If you've gone to our factory to have a look at it.
So high transmission is the glass, right?
Yeah.
So you're not losing some of the energy to the glass absorbing it.
Exactly.
Yeah, okay.
And also because of the cell technology, which we will cover in a little bit, but it's really because of how the HJT cell is kind of set up, you also lose less power overall. And that's kind of it for the RX in terms of the benefits. That there are a lot of benefits that come along with the RX or the Alpha Pure Rs in that sense. I mean, aesthetically wise, it looks great. The mechanical wise, the frame, everything is very sturdy. Again, everything is produced in a controlled factory, and we use not robots, but automation to do a lot of our build. So you can be assured that if something goes right, it would just go right throughout. And if something goes wrong, we can pick it up immediately. There's no such thing as like a human error or anything like that, because everything is just built by automation in itself.
I've heard many people say that about robot or automation control, which is it's very repeatable.
Exactly.
But if you make a mistake, it's very repeatable.
Exactly.
But you can catch it and go back to it. Yeah.
So the key thing about that is because automation uses limits, and so if anything is out of limits, you immediately know. Whereas I guess if you use like a human doing it, there's always, maybe they're tired or they might just oversee something, and you have your human error there. So a lot of our stuff is done automation, but on top of that as well, there is also someone like a worker to oversee what is going on. So if anything does go out of spec, for example, it'll get caught immediately, and then they would raise it up and be like, hey, this is a problem at this station, can we fix it? And then that happens.
Do they test the panels once they're made?
Yes. So we actually do flash each individual panel.
All right.
And we have that data. So if you have an RX panel, for example, that you're just curious to know how it's like out of factory, hit me up, give me an email, give me a call.
You mean serial number linked?
Serial number link EL test.
Wow.
Okay. So you can retrieve every EL that comes out. Or EL, sorry. Another acronym there.
It's got to get you there.
Yeah. So EL is what we call as, I'm trying to pronounce it properly, electroluminescence test. So basically it's just a flash in its optimal conditions. So 1,000 meter squared irradiance, what is the voltage and the current, and trying to give you the best STC conditions as we can, or you would get STC conditions.
So simulating standard test conditions instantly, which is what the panels are rated for anyway. When you buy one, those 480 watt RX panels at 1,000 watts per square meter.
Yes.
At EMS 1.5, 25 degrees cell temperature.
Exactly right.
Got it.
So we try and emulate that. Oh, well, it is emulating that. And it's again linked to serial number. So, and we understand because there's always tolerances throughout different, in every industry. So with that, you can actually find out where that panel and what it is out of the factory. And then from there you can, whether it's okay, not okay, we can straight away have an identification on that.
What is your tolerance range?
We have a 0 plus 5.
Yep.
So we don't do percentages, we just do like a whole wattage in itself.
Plus 5 watts.
Plus 5 watts, yes.
And
plus 10. It's now plus 10.
Plus 10 watts.
Plus 10 watts.
Yeah, I'm just thinking in terms of a 480 watt panel, it's still just a few percent.
Yeah.
Yeah.
But the thing about that is a little bit of insider information here. Usually our panels hit the high for, let's say if it's a 480 panel, we usually go up to 487, 488. And we would just pass it off as a 480. So it's always rounded down. It's
a great business model. Yeah. Promise less, deliver more. Yeah.
Yeah. So you're definitely getting more than what you pay for, 100%.
Yeah.
But that's a nice bit of tidbit from ourselves.
Yeah, cool.
That is the main, I guess, overview of the RX, and that's how it, and the benefits that come from it. Now, just to go a little bit more technical, and this is where we might delve into it a little bit later, but the Alpha Pure RX is also still using the HJT or heterojunction cell technology cells. And that basically means that each cell has layers top and bottom, but they are identical. So because of this identical layers, what happens is that there's a very high bifaciality that we can get out of each individual wafer.
Even though this panel has a white back sheet,
yes,
it has a bifaciality component.
Yes.
How's that achieved?
So basically how we like to think about it is when you think about a cell and how it functions, right? If it comes in from one direction, then it's only get excited like from one side. But if you can get it excited from both sides, then you're able to activate it faster and it will give you more power because now both sides are being used.
Are you saying that the white backsheet's translucent?
So it's not translucent. So how it was kind of produced is we use a white backsheet is because the white backsheet gives you the highest output with the bifaciality factor.
So there's some internal reflection.
There's some internal reflection.
Oh,
Because
yeah.
not all light would be, like
Yes.
there's always a gap between
Yes.
the cells.
We're
So-
talking at atomic levels.
Yeah,
I mean,
yeah.
we hold it up and we can't see through it, but we're not an atom.
Yeah, exactly.
We're not looking at
Exactly.
an atomic level.
Exactly.
And so that little photon, which is subatomic, just goes right past some of those atoms.
Yeah, and then it bounces back.
Yeah, and then it bounces back. Okay.
Yeah. So how we like to think about it is, honestly, if we strip away the white backsheet and you just have it as a dual glass, that's a possibility. But we can't extract the highest efficiency out of that. We rather put the white backsheet on, and that gives you the highest and reliable output of the panel, rather than just leaving it up to chance.
I've heard this stated that bifacial panels are really only suited to ground mount, where you've got some albedo from the ground.
Yeah.
Because you get no reflection off the roof because it's in the shade. But the backsheet gives you that internal reflection.
Exactly. You can always calculate that backsheet and how it reflects because it
Right.
never changes.
Okay.
Yeah, so that's the interesting part about the HJT cells in general, and that's why we like to use them and why we are kind of going forward with this technology as well. It's just because of that. Not just because of the bifaciality, but because of the increased efficiency and everything that it kind of brings across.
Yeah. So I see you've got some a table there where it's saying, for instance, a mono-PERC cell has only 82% bifaciality, whereas the REC alphas are 92%.
Yeah.
Right.
So that's a testing again from our labs.
Yeah.
So at REC, we like to experiment with a lot of things, and you will kind of see it in a bit. We always like to quantify numbers if we have a comparison that we like to do. And so we do actually try and see how our panels perform in terms of bifaciality versus not bifaciality, for example.
Yeah.
So the numbers that we churned out that if you get a tier 1 P1 PERC, you'll get like 82% from it, whereas at REC you get 92% out of that. And that's the bifaciality part of it. Now, on top of that as well, why we like the HGT layout or the system is that it has very low manufacturing process. And how we like to say or like to understand it is it's always like lesser is always better in a way in terms of manufacturing processes wise. The lesser processes you have to get to your end goal and everything else still stays the same. Like that's as optimized as it can get. HJT only has 7 steps. That's it. So there is lesser moving parts and lesser failure points to get to where you need to get to. And on top of that as well, because it's so optimized, that's how we can automate everything in Singapore,
Yeah.
if that makes sense.
Yeah.
Because if there's more processors, there'll be more machines, more costs and everything,
Oh,
etc.
so you mentioned Singapore. So the manufactured in Singapore.
Yeah, so RAC is manufactured in Singapore. The RX is manufactured in Singapore.
Yeah.
So that's, I guess, our in this region, it's home base.
That's
and
your
it's-
home.
Yeah, exactly. Yeah. So I'm very proud of it, and I'm also very surprised because RAC, like Singapore, is a very small. Is a little sunny island.
It's just amazing what comes out of that
Yeah,
place.
exactly. Like to have such a big company.
And no natural resources.
Exactly.
Just brain power.
Brain power, hard work, that's it. And somehow things work. So
Yeah.
it just carries across. Being at REC, it's great. Even though it's started as a Norwegian company, but now it's produced in Singapore and everything comes from there, manufacturing wise. So yeah, coming back to the whole manufacturing process of the HJT cell, 7 processes, which I guess you put this on the screen as per before. And yeah, each individual station is also manned by a worker. So nothing goes wrong. Everything goes wrong, it's fixed on the spot. And again, because it's automated, in and out will be the same or similar. So on top of that as well, HJT cells, because of how it's laid out and how you have percentages of different components, you actually get a more reliable cell. Reliable meaning it doesn't crack as easy. It's pretty flexible. There's a whole video that you show you.
Yeah, I mean, the picture that you've got on the screen of a
Exactly.
finger bending the cell.
Exactly.
That's amazing. Because
Yeah.
I remember, I think it's to do with the thickness of the cell, isn't it? When the cells get thinner, they become more flexible.
Yeah, not only that, I
Yes.
guess. It's also because of the amorphous silicon, that the layers that is
Ah, okay.
injected into the cell. And with that, like the amorphous silicon, as you would know, it's also done for like thin film
Yes.
solar panels before. So it has that flexibility, but the drawback of that was power production.
Yeah.
Because the efficiency of that is really low. So just to delve in a little bit on the HJT cell, the benefits of the HJT cell is just really like in Singapore in general as well, we just a combination of everything that's great, and then we just layer them together.
Yeah.
So you get the benefits of everything that's layered in together. And of course, in some way, the cons are also layered in, but they kind of cancel each other out. So for example, we get the amorphous silicon layer. The pros is it's flexible. Cons is power production is pretty abysmal, right? So to counter that, we put the anti-wafer in, right? Like, and the bulk of it is the anti-wafer. And that produces more power, but then the drawbacks is inflexible. So it's finding out that percentage of how much we want of this versus how much we want of that, and what's more important. And again, each and every iteration and generation that we come out, we are always working on getting that right formula, that right recipe to the cell. And I think the RX, again, as you can see, like it's a 480 watt panel. The size is still fairly similar. Weight hasn't really increased by much, but now it's a 480 watt panel, right? Never in this world that, would I have expected a 480 watt panel to come out as a residential home when it used to be like commercial grade panels, right?
Yeah.
I mean, knowing from your experience.
I know. I'm old enough to remember my first system. In 1991, panels were 75 watt.
And
they cost like $700 each. Well, actually, I think it was $800 each. And they were about the size of this little grey mat here.
Yeah.
You could just put one under one arm and one under the other and carry them onto the roof.
Yeah. But now it's so much bigger, but so much producing so much power. The cost has been what?
Yeah. And these old ones were like 13, 14% efficient.
Yeah.
Module efficiency. And now we're over 20.
Yeah. It's so interesting because it almost looks like computers. Remember your old school computers? And now look at what you have on the table. You just like have a laptop, you have an iPad now.
Yes.
That works the same or better.
Yes.
So it's great to see the technology evolving, and it's always pushing the limits. REC is always trying to push the limits of what it can do.
Yes.
And we're always trying to find that little breakthrough, right?
Yes.
The small little breakthroughs that come through and then expand and work on that to make it more efficient.
I've got to make a little shout out to Professor Martin Green and his team at UNSW, who've actually led the world with monocrystalline efficiency for like 30 years.
Yeah.
So a lot of the R&D actually came from Australia and went to around the world.
Yeah, that was also, that's really amazing, I'm not going to lie.
Yeah.
Like, for it to come from here.
Yeah.
And now I'm here as well, so it's like, wow. All right, cool. We'll go back to the RX and the low temperature coefficient. So we've gone through the panel in itself, the benefits of the panel, the RX, and the cell technology, the HJT cell technology, the 7 steps to get there. And now it's the temperature coefficient. I mean, we've touched a little bit on that, on why is that so important. So we have a minus 0.24%.
Wow.
Yes.
0.24. These panels back in the day were like 0.5. Okay, so you're half what they used to be.
Half.
Which means at the same temperature, they've lost half as much power.
Exactly. Well, the percentage drop.
Your percentage drop will be half as much.
Exactly.
Yeah.
So you will lose half of what you would lose before.
Yeah.
So, yeah.
See if I can do this in my head. So they're tested at 25 degrees Celsius, right? And we put them out in the sun, and they'll be operating at probably 50 to 60 degrees Celsius, maybe even more.
Yeah.
Let's say 60. So they've gone, let's say 65. It's a hot day.
Yeah.
So it's gone up 40 degrees
Yeah.
from test conditions.
Yeah.
So we're only losing 0.24%.
0.24%.
Yeah. So 40 times 0.24. Can you do that in your head?
40 times 24, that's 8%.
That's 10.
10%? Yeah,
I think it's about 10.
10%.
Yeah. So we're losing about 10% power. We used to lose 20% power.
Exactly right.
Yeah.
You can always draw the comparison there.
And if I got the maths wrong, I'm going to put it in the description. But anyway, I think that's right.
Just put it in the comments.
But it actually, for me, is a really big thing because customers get annoyed when you tell them that this panel's, the system's 6.6 kilowatts.
Yeah.
And they look at their inverter and they see 5 point something. And they go, where's my 6.6?
Exactly.
You always got to explain they're going to lose some power, but now we don't lose nearly as much.
Exactly. And the benefits come when you now can then reduce that, right? So if you have a same system of a 5 kilowatt inverter, for example, instead of putting a 6.6 on there, you can put like a 6 because you lose less power overall when it's operating at its max.
Yeah.
So that's the benefits that the RX can give. It's all these little things that you don't see, but when you design a system, you want it to ensure it produces to what it's expected to be. That's where all these little things then come into play.
Yeah.
Yeah.
Now, This is a kind of just a random question, but is there a difference in terms of low light performance with the Alpha Pure RX? Was that a significant change?
Well, it's not a significant change from the Pure Rs, but that's because the Pure Rs in that generation, we have already kind of hit a little bit of a ceiling there. So if you go onto our data sheet, it actually at the bottom right-hand corner, if I can just pull it up really quickly for you. So it has what we call as a low light behavior graph.
Oh, right. Hey, that's cool.
So it does tell you the typical low irradiance performance at the module at STC at different irradiance levels.
Yes.
Right? So as you can see, it goes from 100 to 200. You get about, 90% at 100. But as you get more and more, I guess, irradiance on it, then it starts to curve up. So we think that this is, right now, the curve is fairly acceptable to what it's normally operated at. But it's definitely something that we're looking at as well to see if we can improve that any further. That's one of the factors one of the segments that we're kind of trying and testing out.
Yeah. I can see salespeople saying they work well in the shade.
Yeah.
Or under moonlight. That's not true.
Yeah.
They don't work under moonlight.
It works on irradiance levels, not
Yeah.
just light onto it.
That's
There's a
right.
difference. There's a difference there. Okay, so that's basically it in terms of how and why, some people might tell you, oh, the Alpha PR is producing you more power. It's not producing you more power. It's losing you less power.
Yeah.
Yeah, so everyone can get up to, at perfect conditions, they can get up to what they're rated at.
Yeah.
But in the real world, you're going to have some power losses. You're going to have some trade-offs. And that trade-offs, for us at the very least, we like to reduce that as much as possible. So in terms of producing you more power, it's more like losing you less power.
Gotcha.
That's the angle I think we should kind of look at. So on top of that as well, the cells, again, very automated wise. So everything's just laser cut. So you get less thermal heat on the cells.
Yes.
And because there's less thermal heat or less thermal affection, I guess, infliction onto the cells, it's more sturdy and it's more, how do I say it? It's more reliable.
So what's conventional cutting? How's that normally done?
So conventional cutting, like
Angle grinder? No?
maybe
A wire saw?
maybe back then, in the 90s maybe. I guess earlier days you have machines that literally just, you can have like a little cut in the middle,
okay.
like a mechanical cut.
Yep.
Like it's mostly done mechanically.
Yep.
Nothing is really done, I guess, with laser, like to cut using laser. You can either use, I guess you can use chisel and a hammer if you want to.
Right. So
But-
they can do random fracturing, which you can't see.
Exactly. So if you put a microscope under those, it's almost the same as you use a scissors to cut paper,
Yeah.
right? If you use that, you're going to see jagged edges, no matter how clean your cut is,
Yeah.
unless your scissors is completely razor sharp, samurai sword.
And you don't pause.
Yeah, exactly. you don't get out of the way, anything like that. 90 degrees cut, sure. You might get the same, outcome. But with a laser, because everything is automated, the tolerances, how big it's gonna cut, how strong it's gonna be, and where the line's gonna be.
Yes.
Just zoop, and it's a clean cut.
Right.
Perfect clean cut. So on the image you can see on this slide, if you cut by a laser, you don't see the jagged edges. Whereas if you do like a conventional mechanical cutting wise, you can always see jagged edges. And it's just because of the incision tool that's being used.
And you're showing in the photoluminescence picture that some cracks that have propagated.
Exactly.
Yeah.
So how we kind of extrapolate this is because of the jagged edges. And when you put them together, and because of the jagged edges, there is already weakness in the cells in itself, in the wafer. So when that happens, or when the cells are put together and then it forms like a wafer, then because of these jagged edges and these weak points, they may possibly inflict a weak line, and then that turns into a crack.
You see that with windscreens sometimes. A stone hits it and you've got a little chip.
Yeah.
And then suddenly a little crack after some days starts to grow and migrate across your windscreen.
Exactly, right? Yeah. It's exactly the same thing.
Yeah,
That's a weak point.
Yeah.
You're just going to find the easiest way to get out
Yep.
into, to the open.
Yeah.
So with the laser cutting, that's why we are very confident of ourselves and why we are still using this HJT cell technology and the machines that we have is because of this clean cut that we have. There will be no point will be weaker than the other. And therefore there wouldn't be a path of least resistance because all the resistances are fairly similar or the same.
I've heard it said that when half-cut cells came about, well, I asked this question, why didn't we go to half-cut cells long ago? And someone from the PV industry said it's because it was hard to cut them.
Yeah.
right? But now with laser cutting, you can do it quite easily.
Yeah, and I think it's a technology that we've carried over from our Twin Peaks series.
Yeah.
And the same idea, but different execution.
Yeah.
So that's in terms of the cell. Now you have the cells, we have our panel and how reliable and how beneficial it is, when we talk about the HJT cells in general. Now we're going to layer them all together, and then I want to talk about how we kind of have it in such a way that the panel doesn't have bus bars, right? And you might be thinking, well, if it doesn't have bus bars, then how does it conduct electricity, right?
Yeah.
So we have wires that run across the panel, right? We're not saying that there's no wires. There's just no major bus bar. And how it actually kind of conducts electricity is through the oxidization layer that's on top. That instead of using traditional bus bars to carry the current, we just use this oxidation layer. So with that, we eliminate a lot of the soldering that has to be done on the panel. And so that's why our panels are lead-free. It's RoHS compliant and it's lead-free. So at REC as well, carrying on from our Alpha series, we are always thinking of the environment as we develop our products. It's not. So even for end life situations, right? Nothing lasts forever. It has to end somewhere. But at least we know that at the end of the life of our panel, we know that it's safe to recycle or to be repurposed into another product. And there's always a way to repurpose our product. Might not be as a panel, but as a recycling maybe, or in another way. At least at the end of life, we have plan for it to reach that stage.
Right. I mean, it's becoming a big issue in the industry in Australia.
Exactly.
Because of upgrades. What do you do with the old panels? And mostly it's kind of like munch them up and separate them out into a couple of basic waste streams, metals, minerals, glass, plastics.
Exactly.
But if you can make sure there's no lead, that's a bonus. So you might find that there's a special REC sort of pathway.
A little category by itself.
Yeah, because they know there's not going to be any lead in that mineral. Yep.
Yeah. So I've been talking to a few recycling companies as well, and they're saying like the lead component in it is really sometimes a little of a pain to deal with because it might contaminate the rest of the materials in there. And sometimes if there's lead, the operation gets a little bit more dangerous, which makes sense because there's lead in the holes.
And they are smashing it up, so you probably get some vaporization of that lead too.
Exactly. And we don't want that. Like, if you want to recycle our products, at the very least we can do is to make it as safe as it's possible for the worker or for, whoever that's on site if it's a machine. So yeah, the Alpha series and the Alpha Pure R, Alpha RX now were all lead-free, RoHS compliant. And the way that we do that is through different ways of optimizing the connections of the panel in itself.
Gotcha.
So how we do that is, besides not just having a major bus bar, in terms of the layering of the cells as well, what we do is we have a gapless cell connection. So as the name implies, the cell connections are gapless. And so that's how they just kind of connect.
So no tabs?
No.
Right. That would give you a bit of coverage too.
Exactly. Because it's gapless as well, and you don't have that this little gap, that all adds up. That all adds up inside in terms of the size of the panel in itself.
Yeah, you can look at the cell efficiency and go, oh, this one's 22 and this one's, much the same. But when you look at the module efficiency, which is what really matters.
Exactly.
How much power from an area
that it's giving you.
It's giving you more.
Exactly.
Yeah.
So we have one of the highest, if not the highest, if I'm not wrong, but one of the highest power density. I think that's what we like to call it. The power density of the panel. We go up to, I think now it's 231 watts per meter square. So we're pushing that higher and higher as much as we can. And yeah, one of the ways we're doing it is how do we keep the size the same, but what's in there, can we compress it? Can we put it closer together, etc., etc.? What can we remove out and it doesn't damage anything? And the functionality still stays the same. That's what we want. So yeah, so the slides that we can kind of see here, it tells you, how many contact points, versus a standard 5 bus bar cell panel, which will be pretty obsolete by now, to be really honest. But
can you pause on that for a minute? Because
yes.
I remember you said to me that your wires being round mean they don't shade the cell so much as opposed to a flat ribbon.
Exactly. Because it's round, it also conducts electricity better, right?
Yeah.
Because it's round.
Cross-sectional area.
Exactly.
Yeah, right.
So all these small changes, right? All these small changes help to increase the efficiency of the panel overall, but it's not something that you can kind of see outright. It has, you know, you have to go down to, you know, a cellular.
You're really
level.
squeezing the juice out of the lemon.
We're really, as much as we can milk it, as much as we can milk each individual component, we are gonna do it. We're gonna look at every single portion and see what we can improve from there. Get more out of that. Yeah. So as you can see, thin round wires, no soldering, no lead content, and it looks nice as well. Like there is no drawback to that.
Yeah.
You know, everyone wins in this situation, so why not?
Gosh, I was just thinking, like the first solar cells were produced by the RCA labs back in 1955 or 56. They were 5% efficient. We're over 20 now. That's a 400% increase with the same material.
Exactly. Maybe the size might have grown a little bit bigger,
but the material, you know, efficiency at a cell level,
exactly,
it's 400% more efficiency.
Exactly.
That's a pretty impressive number.
Yeah. Hopefully it keeps going up the same way, that the innovations in technology keeps heading in that direction, and we can get more out of the panel. You know, maybe we get a 50% efficiency panel someday, hopefully. Fingers crossed. So yes, so that's the RX in general in terms of cellular and modular level. So now techie stuff out of the way. Now we're going to talk about why we lay out our panels like that. So if you've seen the Pure R, same thing. If you've never seen the Pure R, this panel might just look very weird to you. And the reason is because your usual panels is usually a half cut cell. You get your whole twin peak design. You get one top, one bottom, right? Pure RX, what we do, same as the Pure RX, build on that. We still have 4 sections now, going from top to bottom or bottom to top.
When you say sections, sub-modules within the panel.
Exactly.
Electrically separate.
Yes, then there's a bypass diode on between each of these modules. So what happens is that when these subdivisions shaded, the diode kicks in, it's bypassed, that section is safe, and you still get the output of the panel.
Oh, so it's vertically arranged.
Yes, so it's vertically arranged. And the benefits of that is because when we look at shading in general, right? Unless you have like a tall tree that's, you know, right there already, that's blocking your panel, then we have a problem. But we have a problem already anyway during the design stages.
Yes.
But otherwise, other than that, if it's a slow creeping up,
it'll be seasonal change. So seasonal shading, as the sun gets lower, the shadows get longer.
Exactly.
And they creep up the roof.
Exactly.
Yeah.
So it's more vertically sound to move in that direction. So that's why we have our sections vertically or horizontally. So if your shading happens vertically, and which is what most shading is anyway, it wouldn't affect the panel as much. And because we have 4 bypass diodes versus 3, we can have up to 25% loss per subdivision versus a normal 3 bypass diode that will give you 33% loss. That's 7%?
Yep.
7%.
Right.
So we're saying again.
So it's more shade tolerance in quotes.
Exactly.
Yeah.
So I think like for me is just like what we're trying to do is we're trying to minimize losses.
Yeah.
We're not trying to push, to sell on it does this and that. We're trying to minimize losses on real world conditions, right? First, we talk about low temperature coefficient, right? At a hot temperature, which always happens, trying to minimize losses there. Now, shading. Shading sometimes is inevitable. And then instead of just trying to, good luck, we try and minimize losses there as well. So instead of getting 33%, we're like, all right, we can do 25%, right? And why not?
And
right?
resistive losses, you've reduced those with the wires.
Exactly.
The
round wires versus thin.
Yep.
That increases our, overall efficiency of the panel as well.
And I guess the half-cut arrangement also, I squared R, reduces resistive losses.
Exactly.
Yep.
And the laser cutting, like everything is just there to minimize losses out of what you get from the panel.
Yeah.
So on a data sheet, it might look, these two panels are fairly similar. But when you put it on the real world testing, these losses that you have eventually are minimized overall.
Yes, everything from temperature, the angle of the sun, whether those round wires are actually kind of like passive solar tracking. The sun can get around them at lower angles.
Exactly, and the bifaciality. And everything like that.
Oh, so much to it.
Yeah. Well, very in on our little losses minimization.
Yep.
On top of that as well, I just want to kind of also talk about the layout of the frame and the panel in general. So one of the things that we have and carried over is the clamping zones is still as wide as ever. You're not losing out on anything.
Yeah, we covered that in a previous video, and I'll link that up here. But It was amazing when you explained to me that with those, what do you call the bars across them? The support bars?
railings.
The railings?
Yeah.
Across the middle of the panels.
Oh, sorry, the support bars at the back
Support
of
bars
the
at the
panel.
back.
Yeah.
Incredibly, make the panels much stiffer and
Yeah.
therefore bigger range of clamping.
Exactly. It just gives so much more flexibility to what
Yep.
you can do on the
Yep.
roof. And hopefully that will allow for more interesting designs. Or if you have troublesome design, at least you still can put, solar on your roof instead of just going, sorry, your roof doesn't really fit. That's one of the benefits I think that the RX can give. And a lot of, on top of that, is just the care for the environment. And, we talk about, so then we talk about cells, we talk about the wafers, we talk about the production processes. We talk about overall aesthetically and the panel, why it looks like that, why it's designed like that, why it's weird like that. And of course, we'll touch a little bit on the end of life as well in terms of the Pure RX. What we're trying to do is as well trying to push that more into fruition in terms of trying the end of life and how that kind of fits within acceptable standards. Where does it go after its end of life? What's the plan, after 25 years? Etc. etc. Not to say that the panel will last, 25 years. It definitely will last longer than that.
What's the warranty, by the way?
So it's 20 years, but if you're through an RCSP trainer, it's 25.
25 years. Now, is that just a performance warranty or is that the full product
Both
warranty?
product, performance, and we also have labor warranty on top of that.
Label? I haven't heard that one.
So basically, at REC, we do understand that sometimes installations and replacements may happen. Right? There's always, nothing is ever 100%, right? As much as we try to.
Yeah.
Again, we're trying to minimize losses.
A meteor.
Yeah. Anything can happen, right? So we know that there will be hiccups along the way somewhere.
Yes.
And so on top, to kind of counteract that, if it's an REC problem, we will admit it. We will face up to it and we will pay for the installer to head out there, do their job, do the panel replacement at no cost to you. On top of that, the warranty actually stays with the customer. And what does that mean is, say they got installation from company A and say company A decides to, they decide to retire and they need a new installer to kind of do the installation.
Yep.
That's perfectly fine.
So it stays with the customer. Okay.
It stays with the customer
so
and
you don't have to kind of chase an installer who's gone out of business.
Yeah. Or you don't have that worry. You don't have to have that worry of who do I contact now that this and that has been gone, etc.
Yes.
Just come to us. Come to us. We'll solve it for you. If there's any problem with your system, just come to us. We'll settle that for you.
Fantastic.
Yeah. So on top of that as well, talking about warranties, right? So under the 25 years and why we kind of measure 25 years is, we can measure more, but 25 years is where we kind of think that it's a good way to kind of show the efficiency and life of the panel. So
I've got some panels that are 40 years old here. They still work.
Yeah, exactly.
But their fill factor has dropped a lot.
Tremendously.
So, yeah.
Yeah. So for us, for example, like the Alpha panels, the Alpha series, after 25 years, you still get 92%. And that's
92%.
That is what we call the worst case scenario.
Yeah, right.
So at the 25 years, for example, you might still have 93, 94, 95%.
Yep.
You still have that. And so why we go up to 25 is because, 25 years is a pretty long time.
Yes.
But we show you that at 25 years, you would still get, higher than 90% of what.
You'll be on to your third inverter by then.
Yeah.
Yeah.
True. But you still get what you expected to get, like your system size.
In fact, it's probably the longest warranty of any product in the home. I'm just trying to think of anything would have apart from the roof.
I mean,
yeah.
Does your life insurance count?
That's true. It's not a warranty. You're not guaranteed to live.
True.
I'm going to sue you because I died.
from the other side.
Yeah, that's right.
Now you kind of mention it. Yeah, I think that will be the longest warranty life, ensured warranty life you have on your product. So, yeah, and again, we're not saying that it only lives for that long, but at 25 years, that's what we can guarantee.
How long has REC been in business?
So interesting that you asked, because we've been in business for over 27 years now.
Oh, wow. Okay.
So if you had our first panels right when we first started,
yes,
you would have got the 25-year mark and over. So you don't have to worry would you still be here in 25 years? We've been here for 27.
Yeah.
Right? The first people that got our panels would probably ask the same thing. Will you be here in 25 years? We'll be here for 27. So,
yes.
So we don't have to worry about that. Like, we intend to keep going. 27. Hopefully we can make it to 50.
And it means you've survived the solar coaster. So you've been through all the ups and downs in the industry and you're still there.
I think that never ends, does it?
No, the solar coaster never ends.
Never ends.
Governments will ensure that.
Yeah.
With policies. Yeah.
So the ups and downs are always there, but we have always, rolled it out, and we're still here, still innovating, still trying to push the limits, the boundaries of what solar panels can do. So yeah, and it's a very interesting sector as well. Moving forward, we want renewables to be a bulk of what is coming in terms of power wise, and we always want to be at the forefront of providing that. Besides that as well, not just providing power, we want to also ensure at the end of the life of these products, where does it go? How does it not affect whoever that's trying to, again, repurpose our product to make it safe for, I guess, everyone at the end of the day. Yeah. So that's it in summary. The RX is really just pushing the boundaries of the pure R. A bigger panel, a bigger wattage panel. It's a little bit bigger, a little bit heavier, but all the benefits of the REC brand and the pure R is now just carried over to the RX. And yeah,
so it's an evolutionary improvement on the Pure R series.
Exactly. Yeah. And again, it's gonna just keep evolving, and we're just gonna keep pushing the boundaries of what we can do of these products.
We'll have the RX2, the RX3, maybe.
Maybe different letters, longer names, probably.
Cool. Well, it's been really interesting learning more about REC's panels, the company, the history, the commitment to making a clean environment, and that's fantastic. So thanks very much for coming.
Thanks for having me. Thanks for having me again, and always a pleasure being here.